Good afternoon, everyone who was able to take the time and take in the webinar here today. Today we have Anastasia Kubinec with us on a little bit of a repeat of the meeting we had in the fall. Anastasia is going to talk to us about crop rotation and focus a fair bit on Clubroot, which seems to be lurking around Manitoba more and more all the time. We'll let you take it away here, Anastasia, and I think it's safe to say if anybody's got any questions during, you can forward them to me and I'll interrupt and bring it up as we see fit. Okay.
Okay.
Go ahead.
Thanks, Soren. So thank you very much for inviting me again. As Soren said, this is a repeat of what I had presented to the group in Virden kind of right before Christmas. And I'm going to be talking about crop rotation and then also about the clubroot that we've been finding in the province, and then some of the strategies of how crop rotation can help with some of the clubroot issues. So my presentation is crop rotation and clubroot risk reduction. So some of the things that I'm going to cover in the presentation are the rotational effects between crops, crop on crop stubble. The charts that I'm going to be showing you've probably seen quite a few times before. They're the charts that show up in Yield Manitoba. They're based on mask insurance information on yield from contract holders. So that's where we're getting that from. It's not small plots, it's real fields throughout Manitoba and over a number of years. Yield potentials and returns based on those crop rotations, how crop rotation can affect pest buildups and breaks, and that in turn can affect some of your potential returns on what your investments are. Clubroot risks and reduction techniques, including crop rotation, but a lot of other things too. And then some of the optimal crop breaks. So if you're looking at, where's the best place to put soybeans into your crop rotation, or peas or wheat or canola, there is some information through what MASC has collected that kind of shows, out of, 1 and 2 or 1 and 3 or 1 and 4, what kind of is that best break. So this is just a few assumptions. This is the crop sequence yield chart. Again, I said you've probably seen this in Yield Manitoba before. It's basically on the top here, we show crop planted. On the side here, we show previous crop or the stubble that you're seeding into. So for example, spring wheat on spring wheat stubble, 85%. This is based on kind of an average of what things would be. So every crop in consideration of what stubble you're planting it on, the average would be 100%. So this is showing, is this below average, above average, and just kind of highlight it. Oops. Highlight a few things. Crop on crop, I've highlighted here in yellow. So that's really the ones that we do not recommend at all. So for example, canola and canola, you're losing about 13% compared to all other crops of yield just by having that crop consideration. And to go even further, I've highlighted here in green the crops that, or the combinations of crops on what stubble gives you kind of over that 100%. So we can see here crop planted, a lot of our broadleaf crops, canola, flax, field peas, soybeans, sunflowers, you throw them on wheat, you're going to get over 100% of kind of the average yield every time that you try that. When it comes to, say, spring wheat, if you're planting it on broadleafs, canola is 100%, peas, soybeans, sunflowers, that's kind of the combinations that a lot of us have heard about and have seen probably happen on your own farm. If you put a broadleaf after a cereal, it tends to do better than a broadleaf on a broadleaf. Some of the ones here where we do see really, really big increases of, for example, oats on soybeans. There's other things going in play there too. Soybeans, if you are a soybean grower, you're probably using glyphosate. You probably have a very clean field. It's black. You are seeding that crop right into there. It's probably coming out of the ground faster. It's probably weed-free for those first few weeks of that crop emerging, which goes towards yield at the end of the day. So those are some of the other interactions that we see in here, but aren't always explained by, just planting one crop on the other crop stubble. So that's what I'm going to go into a little bit further in this presentation and some of those interactions. So economic opportunities. This is something that we've kind of gone to after looking at those crops on crop stubbles, because at the end of the day, you're probably going to make your decisions on, which crop on what stubble is going to yield the most and therefore provide you the most money. So here I have made kind of a 5-year chart. I've taken a few different crop rotation sequences that we have seen in Manitoba over the past few years and just kind of showed what some of their economic returns are. So I call this kind of the Manitoba Classic. This, in a lot of areas of Manitoba, was the crop rotation and maybe still is. So spring wheat canola, spring wheat canola. We do get a yield boost of putting canola on spring wheat. We really don't on getting spring wheat on canola. I just use some of the economic return numbers. So this is based on actually the 2007 or 18 cost of production numbers. I know 2019's out, but I haven't updated. So we're making about $142 over the 5 years. If we kind of increase to another crop or change it up, so soybeans, corn, some producers are doing this. And we are seeing that we do get a bit of an increase on our corn yield after soybeans. Soybeans gets a little bit after corn, but economic returns over those 5 years aren't quite as lucrative as it is with spring wheat canola. But in both of these situations, we're only looking at more of a crop alteration, not really a crop rotation, because we just have 2 crops. There's no rotation there. It's just crop on crop on crop, and you've never changed anything up. So if we make something a little bit more diverse and get into an actual rotation where we have canola, oats, and soybeans, so we do have oilseed crop, a cereal crop, and a pulse crop, we are seeing a little bit of benefit of oats on canola, nothing for soybeans on oats, a little bit on canola on soybeans, and we can make a little bit more. So this is based on what are we actually getting per bushel for that crop, some of our yields are, and then actually increasing the potential for those returns because we've increased our yields just slightly. Then our third one here, we made it extremely diverse. We're maybe using some crops in here that don't necessarily yield or maybe make the most money for some producers like field peas. But we are seeing that, canola after corn, we're getting a huge increase in yield. So that'll make up for maybe that reduced yields that we do get for field peas. So a little bit more diverse. We're not really making any more money, but if we start looking at some of the other components that we don't necessarily consider just looking at crop on stubble, it can actually show that maybe we would make a little bit more money with this more diverse crop rotation. So just some of the things to keep in mind are, first of all, disease. We live in Manitoba, we have a fantastic growing season, we get adequate rainfall, sometimes too much, sometimes too little, but usually is adequate. We have lots of heat, we have long growing seasons, we can grow lots and lots of crops, but with that too, we can also grow a lot of different diseases. So what I have listed above here are kind of our typical diseases that we do have for Manitoba, and I know there's a lot of talk about clubroot right now, but a lot of these diseases we do need to keep in mind. Fusarium head blight has been a real thorn in the side for producers for the past 20 plus years. Blackleg as well. We do have clubroot in here, Aphanomyces in peas, definitely in the Burden and Southwest area. That is becoming more of a concern. Root rots, Phytophthora in soybeans, many. We do have a typical recommended break year between crops that do have this disease. So just because you grow spring wheat and then you want to flip to grain corn, they have the same disease profile. So Fusarium is still a concern in all of them. It affects the plant a bit of a different way, but it's still a concern. Root rots as well. But then there are other diseases that don't go back and forth. So using spring wheat and grain corn again, something like Goss's wilt, very important for grain corn, doesn't affect spring wheat. When talking about something like clubroot, it's kind of like Goss's wilt for clubroot. It affects canola, but none of the other crops. But if we want to look at a disease that affects a lot of the broadleaf crops, something like sclerotinia affects most of the broadleaves that we do have out there and can be extremely important in things like canola and definitely important in other crops like sunflowers. So you need to keep that in mind when you are considering your different crop rotation, how many years you want to have between crops. You do need to be looking at the disease and what your break year is. So here I have up here our break year, Fusarium, 2 years. We want to wait between those crops that both carry it. So 2 years of a break, not, you know, just 1 year crop in between. Root rots, 3+ years. Goss's wilt, 2 years. Clubroot, we actually say 3+ years. And that goes to an actual inoculum, or what is actually causing the disease and how long it can stay around in the environment. And that's either, you know, staying on the stubble with something like blackleg, or actually staying in the soil as a resting body, and that would be something like clubroot. So if we introduce kind of disease pressure to our rotation, we had the same ones as before: our spring wheat canola, soybean corn, our little more diverse canola oat soybean, and then our really diverse. I showed here with these first two ones where we're not really having that crop rotation, but just an alternate crop. We actually start to see yield losses. So here I'm having canola because we probably had canola the year before spring wheat. Just that 1 year break between those two canola crops, I just put a hypothetical number there of we're losing about 5% yield. It could be more than that, it could be less than that. But if we looked at the previous slide, we needed a 2 year break for something like blackleg. We need 3+ years for clubroot. We're not giving enough time for that inoculum to break down and not be there and to infect that next crop. Spring wheat, I'm saying about a 5% decrease too. And the one I'm concerned about here is fusarium head blight. It definitely does not give enough time for that to break down. If we have a wet year, we're going to have infection, we're going to have yield loss. So instead of having our $142 per acre over our 5 years, we're now down to about $132. Looking at soybeans and corn, it's the same thing. Soybeans, I'm worried about a lot of those root rots. Corn, I'm worried about fusarium. I'm also worried about Goss's wilt, and that's dropped our economic returns down again too. So just that simple consideration of what crop you're growing, how many years between that crop that share that disease, it can start to reduce your economic returns very quickly. Or it could increase your economic returns very quickly just because you're putting in an extra break here. So I've said here in this scenario, because canola and soybeans, they share sclerotinia for sure. Not as much of an issue in soybeans as it is in canola. I'm saying there's no yield loss there. Oats, I've got those 2 years between my oats, so I'm not as worried about some of those diseases. So I'm going to maintain that same economic return that I started with. And with the really diverse one, I'm going to maintain that as well. So this one, even though at first glance, maybe it didn't look like the most profitable rotation, if you start to consider things like disease, it actually does start to look more profitable. So a slippery slope when it comes to crop and only a 2-crop kind of alternate plan, and then potential for an economic opportunity when we come to these crops with a little bit more diverse rotation and a little bit longer breaks between some of those crops that carry the same disease. So now I'm going to switch gears a little bit to clubroot specifically. I will go back to crop rotation afterwards, kind of in a general sense, but I really do want to talk about what's going on in clubroot in the province here. So clubroot is not new to Manitoba. We were finding clubroot in vegetable market gardens back in the 1920s. When it comes to canola, our first clubroot cases that we found were through spores. We did not see symptoms in fields, and that was back in 2011, 2012. So in Manitoba, we did start actively looking for clubroot, and we started actively sampling soils back in 2009 through our province-wide canola disease survey. Prior to that, there was a fairly intensive survey around Brandon, but in 2009, we started doing the entire province. So what we try to do within a year is we try to look at what our annual seeded acreage is, and we try to survey about 2% of that annual acreage. So it comes down to about 180 fields throughout the province where we are testing. So back in 2000, or this is kind of our cumulative over 2009 to 2014. You can kind of see here in very small letters, these are all of our rural municipalities. They are colored, so we have white was not tested, so some of the areas we hadn't been able to get to. Green, we were finding very, very low levels of spores per gram of soil, so in a lot of cases it could be 0. Yellow, we were finding a few more, up to 10,000. Orange, we were finding 10,000 to 80,000, and in red, we actually did find symptoms, or we found higher spore concentrations. So as I said, Our first soil spore concentrations, we were finding extremely low levels back in 2011, 2012. Our first cases where we actually saw symptoms in the field were in 2013. And that was found specifically through the canola disease survey, and then also from a farmer submitting a sample where he had been out swathing, found a patch that was, the canola was dead, it was taken over by weeds, wasn't quite sure what was going on. It didn't make sense with his spraying pattern, seeding pattern, what he knew of the field, which he had been seeding for many years, and started pulling up plants and started to see galls on those roots. So called us, and that's where we found that field. So very, very low levels up till 2014, not very many fields where we did find those symptoms. So at this point in time, 2014, we had tested 473 fields. We had 46 fields that were positive, as I said, very low levels, 2 fields that had the plant symptoms. Fast forward 1 year, we did realize in 2013, when we did find the 2 fields that had symptoms, that there was a bit of a discrepancy between the labs with the results that they were giving us. The one field where we did send the root away, we were unsure whether or not it was clubroot. It looked like a pimple or a nodule on the canola root. We sent it to 2 different labs. One came back positive, one came back negative. We sent more samples from that one field, and it was about 3 times in the one lab before it came back positive. So we started to question some of their protocols, and they told us that they were not able to get a positive reading on clubroot if it was below 100,000 spores per gram of soil. So when we took it to another lab, which was the University of Alberta, that they were actually able to test down to 10,000 spores per gram of soil, they always came up positive where the other lab did not. And we felt at that point in Manitoba agriculture that we would really like to know earlier than 100,000, or when we were seeing larger galls, that we had clubroot in the province. So we developed a program where we had a lab set up. It was through the Manitoba Canola Growers Association, and we were able to use the protocols from the University of Alberta and test soil where farmers had no idea whether or not they had clubroot, down to 10,000 grams of spores per gram of soil, and even lower than that. They have actually developed the protocol to test down to 1,000 spores per gram of soil, so very, very low concentrations. And we felt that we should probably do a baseline study throughout the entire province. So every township and range combination in the province got tested, and that started in 2015. So these next few slides that you're going to see the numbers that we've tested go up quite a bit, and you're going to see our positives go up quite a bit too, because for the sheer amount of fields that we were testing. So in 2015, started our baseline study. We found a couple more symptoms that year as well. Up in the Swan River region, we had an agronomist call and say he had 4 fields that had found symptoms in, and we confirmed those. We had our Westlake Gladstone from 2013, Louise from 2013. We also found symptoms in Pembina, and we found symptoms through Portage La Prairie. So not only were we finding symptoms through our canola disease survey in 2015, but we actually had more producers and their agronomists actively coming and asking whether or not it was clubroot. They wanted that confirmation to know for future management. So at the end of 2015, we went up to 731 soil samples tested. So if you're keeping track, we increased our fields by about 300 that year, and 113 individual fields were found positive. So we went from about 46 to 113, so a big jump there. But please keep in mind, we were testing a lot more fields. And we had an additional 6 fields that had plant symptoms. So we were up to 8 fields. We found 6 fields in 2015. So at this point, we were very concerned. We were finding more clubroot, but we were very thankful that we had actually initiated this lab to test to these lower levels, and that we were doing this baseline sampling to hopefully get a good idea of what was going on. So fast forward to this year, 2018, I'm sure many of you had read in the paper or heard on the radio, or maybe heard your neighbors talking about more clubroot being found in the province. Again, so I'm just going to give you kind of the results. We went up to 294 individual fields testing positive. So that's in combination, you know, everything we'd found up to 2015. We finished our baseline samples throughout the province. We found a few more fields, but the big number is we were up to 33 fields with plant symptoms. So 15 new fields were found in 2018 alone. And those were in the rural municipalities of Lorne and Dufferin. We found a few more in Pembina, Louise, Swan River, Westlake Gladstone, and Portage. So it was definitely becoming obvious that we had some hot spots in the province. Kind of this corridor right here, oops, my mouse isn't working. This corridor right here was definitely seemed to have more clubroot. We had kind of the municipalities around there as well. They're now testing yellow to orange, which was showing that we were having more spores. Same thing around Swan River. Bozeman was orange, Roblin, Shell River, Hillsburg was orange too. So we were seeing definite hotspots. So one thing that we wanted to look at was the frequency of canola that was being tested or being grown in some of these rural municipalities. And we found that in the municipalities that were testing with higher concentrations, we also had a higher frequency of canola being grown in those municipalities, which I don't have that one here. But just to talk about what's going on here with these spore levels, because there always is a lot of questions about that. And producers wonder, you know, what does this really mean? Like 80,000 spores per gram of soil seems like a lot, but where we're starting to see symptoms in Manitoba is at 80,000. To put that in perspective, what they're seeing in Alberta in a lot of cases is they're in the billions and trillions. So 80,000 really is kind of a drop in the bucket to what they do see there. So initially what we saw here, this is our testing capacity with PSI. The Manitoba field concentrations in 2015 were all around under that 100,000 to about 1,000. Field symptoms at about 100,000 is what we are seeing in Manitoba and what they've kind of indicated in the literature throughout Western Canada and in Europe and wherever else they're seeing clubroot, because clubroot actually is a worldwide problem. We don't just have it in Canada. Some of the earliest germplasm that we were testing in Canada for resistance was coming from Europe, it was coming from New Zealand and Australia. This is a disease that's worldwide. And here's where our Alberta concentrations are. So just looking at the magnitude of where we are versus where Alberta is, you know, we have a lot further where we could go, but we would really like to stay kind of in these lower concentrations. And that's why we're being very active right now, talking about clubroot, talking about getting tested, and trying to mitigate some of the risks that you could have to develop clubroot. So fast forward here from 2015, we now are seeing our levels up between 1 million and 1 billion. So that definitely has increased. We are finding fields that probably the clubroot symptoms have been there for a few cycles of canola. The producer did not necessarily realize that was the case. When you start looking at clubroot and seeing it in fields, if you can kind of look around wherever you're sitting right now, if it's at your kitchen table or at your desk in your office, hopefully somewhere warm, the patch that we typically see for clubroot is probably the size of a fairly big kitchen table. So not really that big. But once you're looking at that patch, and I've walked into some of these patches, the very center of the patch, you're going to find plants completely dead. You pull them up, there's galls. If you start walking, you know, 10 feet, 2 feet, 4 feet, 6 feet, 10 feet out from that center of the patch, your symptoms become less and less. And by the time you get to the very edge of that patch, your canola looks beautiful. You have pods, you have yield, but if you pull up those plants, there still is some very small galls happening on those plants. So it's kind of makes sense as to why Alberta could have gotten up to this stage. The first agronomist that really identified clubroot in the province, Orchard, and his first name escapes me, and I'm sorry if he's looking at this. But when he first saw it, he didn't really know what it was. And it wasn't until he went out and actually pulled plants that he realized, you know, something was wrong here. And then he had to do some research to figure out what was going on. And luckily he had done a project in school about clubroot. So he was able to identify it at that point. But then he even says, Dan Orchard, that's his name, thinking back, he'd probably seen those patches in those fields for years and just attributed to, you know, it was a drowned out spot. Maybe it was a spot where the sprayer overlapped and the canola had died. It was something else, and Clubroot never even crossed his mind because it wasn't a disease that was widespread in Western Canada, and it wasn't one of the ones that we were looking for. So left unchecked, Clubroot can advance very quickly, both in concentration. So you start here and you move here every time that you grow another canola crop or a host crop. So finding it at this stage, even though very frightening, makes you really wonder what you're going to be doing with your next crops if you can ever grow canola again. I would much prefer that producers find it at this stage, a few plants, a couple of galls, or get their soil tested and find it at this stage. Then get to this point and have, you know, acres and acres that are affected by Clubroot. So it's just to keep that in mind. Finding these spores at low levels, being able to prevent it getting up to these levels is the way that we're going to continue to grow canola, and we're going to be profitable at it. And that Clubroot's going to be a management thing that we do. It's not going to be something that manages your rotations in the future. So increasing risks for Clubroot. A few questions. Do you farm in an RM where Clubroot's identified? Plants with symptoms or high concentration levels? Just scooting back a couple here. So I'm assuming most of you probably are farming in this area where, yes, we are seeing some spores and we have identified them, but we're not seeing a lot of symptoms. So that's one thing to ask yourself. Higher concentration levels, you're probably a little bit on the lower end still. So maybe your risk is a little bit reduced there. So in Alberta, they estimate that Clubroot moves 30 kilometers a year from a previously infected field. So if you start thinking about how far are you away from those areas that do have symptoms, how far are you from Portage, how far are you from Somerset, Manitoba, how far are you from Swan River? If it's moving 30 kilometers a year, you can start to calculate how many years. If it's moving towards Verdun area, it is until Verdun starts seeing symptoms. So sometimes it's not that long. Do you farm in a rural municipality with a high percentage of canola acres? Over 40% of our arable acres in Manitoba are on canola. It is one of our most profitable crops. We can grow it without an issue. We have the equipment and we have the knowledge how to grow it. But if you're in an area with high acres of canola, you are putting yourself at more of a risk. So here's where my map came in that I was looking for before. So anything here with kind of that pinky or red, we are looking at greater than 40% of acres within that specific municipality do have canola. So if you kind of remember back to the areas that were seeing symptoms, Swan River, Westlake Gladstone, Portage, even though Portage is not growing canola, they have a high percentage of crucifer vegetables, or brassica vegetables, which are in the same family as canola and are still susceptible. And down here, Lorne, Louise, Pembina, they also have very high acres every year that are canola. So this really does indicate, you know, where some of those risks are. If you're growing a lot of canola, you're probably at a higher risk just because you do have that crop that is susceptible. So in the third one, do you grow canola? So every time you do grow canola, as I indicated before, if you do have Clubroot, it just increases just a little bit every year. So it is a host. So our shepherd's purse and wild mustard, anything within that brassica family of weeds are all hosts. So anytime you grow canola, or maybe you aren't controlling those brassica weeds within that field, if Clubroot is there, it's potentially increasing the spores in the soil. So those are our three main risk factors. Do you have it in your rural municipality? Do you farm in a rural municipality with lots of canola being grown? And do yourself grow canola? So one thing that we have known for a long time is kind of this projection of where they thought Clubroot would go. So here's Alberta, here's our epicenter. So annual index for development, very high, 20 to 25. But if we start scooting across to Manitoba, we're even higher. So this is where a lot of, I know my concern, I was the oilseed specialist since 2008. I'm no longer the oilseed specialist. The new person's name is Dane Fraze, very smart guy. But I know when I first saw this, I was really concerned. We hadn't really even found Clubroot yet when this came out. But I was concerned if we ever did get Clubroot, you know, we do have the potential for it to get very bad very quickly. And the reason for that is because of our moisture. With our soils being moist most of the time, if not saturated because of the rainfall that we do receive, that is ideal for clubroot. Clubroot lives in the soil. It's a soil-borne pest. It's called a slime mold or a zoomyces. It moves with water. It moves when the plant is sucking up water, and it's going to move towards those roots. So with those great moist conditions, grow great crops, but perfect for clubroot. So that's where some of our concerns are, and where we really wanted to be proactive in trying to reduce clubroot from really getting established in Manitoba, because there is the potential for it to get quite bad. So just going back to university here, we have kind of our disease triangle. We have our host crop, which I've been talking about, canola. Hosts for clubroot, we have our environment. We have those wet conditions, warm conditions, awesome for disease, awesome for clubroot development, and we have our pest being clubroot. So kind of where we get the three interaction here, we get that disease triangle. And this is really what we're trying to reduce, and kind of reduce this area where they interact. So yes, you're gonna go canola. Canola is a great crop. Yes, we have the environment to have the pest, but if we can take this pest out of the equation or reduce the chances for this pest developing, we've reduced this disease triangle. And that's really, at the end of the day, the one thing that I want you to take home. If we can reduce clubroot spores in our field, or the potential for them developing in your field, you are going to reduce the potential for getting clubroot in that field and in your operation. So just to give you an idea of what clubroot looks like, you've probably seen pictures of it. This is from Manitoba this summer. Dane Fraze took this picture at a field that we went to investigate. It was actually at a producer that was having a field day. He went to go put up his signs. He had a strip of canola that was clubroot resistant and a strip of canola that was clubroot susceptible side by side. He saw a funny patch. It stopped as soon as the border of the resistant canola was there, and he went and pulled some plants, and lo and behold, he had clubroot. He never knew he had clubroot. He had grown canola there about 3 years previously, had never seen patches like that before. It was on the side of a hill. He thought maybe it got dry and there was a little bit of drought stress. It was an area where there is some gravel ridges, but never would have assumed that he had clubroot. So it just goes to show you that if you're not looking for it, you don't necessarily know it's there, and maybe it takes something like that strip trial that producer had to even realize that you have it. So this is from his field. Definitely it tested positive. Not those huge potatoes that you see growing on the bottoms of plants that maybe you've seen in the Western producer, but definitely there is swelling of the roots and the clubbing, which is kind of the typical symptom of clubroot. So this is just some more pictures of clubroot. I pulled these off the internet because I didn't have any great ones myself. Really, you could just start to see by areas of prematurely ripening. You may assume it could be sclerotinia. You could assume in years it could be blackleg. You don't really know until you go into the field and actually pull the plants whether or not it is clubroot or some other disease there. So that's why going in and scouting, pulling plants, figuring out what's causing those diseases are really important. This is another picture that I pulled from, again, this is from Alberta. There was a father and a son farming together. They ran out of canola seed, which I know happens. I farm in Holland. It happens at our place too. Went into town to go get some more canola seed. They ran out of that specific variety, so they put in the variety that they had seed left of. So they started by seeding the variety that was resistant, which they didn't, that wasn't really something that they were looking for, and they picked the same company's variety. It happened to be susceptible, and you can see the difference. They got about 50 bushels an acre on the resistant side, and they got about 15 on the susceptible side. So that just shows you how that resistance can really make a difference. So all this green that you see here, it's not canola, it's weeds, because there was no competition because the plants were dying. This nice swath that you see here, that's their yield, and here they have limited yield. So using resistance genetics when there is known clubroot, either in the area, in your own operation, really does pay dividends. It's the difference between having a crop and really not having a crop. So going back to concentration, it's really all about the numbers. And this is from Dr. Mary Ruth McDonald from University of Guelph. And I've got to say, this is the best visual that I've ever seen for clubroot. So this is all looking at spores per gram of soil, which I've been talking about. So this is all Clubroot that you're seeing here. This is when the spores per gram of soil are under 1,000. This is when they're about 1,000. So you can kind of see this odd, tiny little bump right here. This is when they're about 10,000. So this is also under lab conditions too. So the symptoms are a little bit greater than what you typically would see in a field, but just for visualization. This is 100,000, and then this is 1,000,000. So you can assume here, you know, you probably don't have any yield loss. You maybe have some yield loss, and you're probably having yield loss here. But unfortunately, farmers are busy. You can't look at absolutely every acre. It might not be till you start seeing that great yield loss that you're finding it. But wouldn't it be nice to know here, when there's really no galls, no yield loss, that you have an issue? And then you can make changes to your crop rotation, to your scouting practices, maybe to your variety selection, to ensure that you stay under here instead of getting up to here. Now, so I'm not making you guys quite nervous. If you do get up to this point, we can get you back down to this point. This doesn't mean that you're never growing canola again. Clubroot, as you'll read in the media and in research and newspaper articles, is a long-living soil-borne disease. They say it takes about 20 years to get rid of it, but there is research out there that says if you can have a 2 to 3 year break between your canola crops, even a 2-year break, you can actually reduce your spore levels by about 50%. So yes, 500,000 is still, 500,000. So you're still in this range. But if you had a 2-year break here and then a 2-year break there, by the time you're growing canola here in about 12 years, you're probably down to this level again. And you may be having a little bit of yield loss, but you're keeping it manageable. And the longer that you keep that rotation and you're using resistant varieties, which I'm going to talk about in a minute, you have great canola yields, you have a good crop, you're still making money in canola. But it's to make sure that we don't get up here, or if we do, we're taking really active measures to get back down into this range again. So Clubroot is not just an Alberta issue. We have 33 fields with symptoms. We probably have more, we just don't know about them. Our first was found in low levels in 2011, and that was just in spores. Our first field symptoms were in 2013, and we found 15 new fields in 2018 alone. So we do have Clubroot, but to kind of put it into consideration, symptomatic fields, Alberta found 2,700, or they're at around 2,700 fields that they know of right now, and they're finding about 300 new fields infected every year. Saskatchewan, at the time that I posted this, and I think they came out with a few more fields since then, they found 37 fields just in 2018. So if you are looking for it, you are going to find it throughout a province. But Manitoba, in the scheme of things, we are finding it. We've been talking about it for a really long time, but we're not to where Alberta is. So how to determine if you have Clubroot before you have galls? You can soil test, yes or no. The Manitoba canola growers, if you look on their website, they are offering a free soil test to farmers. If you are a member in good standing, I would say jump on that. If you're going to pay for it on your own, you're looking at about $100 to $125 a sample. I can't remember off the top of my head how many they offer, but I know it's at least one. It might be more than that. So you can go test a field where you maybe have concerns. Maybe it's a field that it's just not yielding the same as everything else, and figure out if you do have Clubroot. And if you do, you can take measures. If you don't, that's great. Some labs can provide you the concentrations per gram of soil. The one in Manitoba does. It's called the Plant Surveillance Initiative Lab, or PSI Lab. There's other ones that are just going to give you a yes or no. There is some limitations to soil sampling though. You can dilute your concentration. And when you're taking a soil sample for Clubroot, it's a bit different than what you're doing for your nutrient analysis. You're not taking your 0 to 6 and your 0 to 24 cores. You're using your garden trowel, either yours or maybe your wife's, and you're going to either your field entrance or an area where you know you have issues, and you're taking just about the top 2 inches of soil, scooping it into a pail. We do recommend that you take it from more than just one spot. We do recommend a bit of a W pattern going up and down the field, about 20 paces between each of the points of the W, and taking your scoop. But if you hit one hot spot and 4 spots that don't have any Clubroot at all, you're going to dilute your sample. The recommendation from Alberta is go to your field approach. Here in Manitoba, we say go to your field approach, go along water runs or anywhere that water pools. We don't just find it in field approaches. We're typically finding it along the water run. In one of the first cases that we did have, actually the first two in 2013, one was where the river in the spring tends to overflow the road and pool in the field. And that's where he found clubroot. In the other case, it was along a water run, even though it was a very, not a huge depression of a water run through a field, we found it kind of at the top of the water run. So that's where the water would have settled and where those spores and the soil that they're adhered to, because that's how it moves in waters, it's adhered to soil where it kind of settled out. And that's where we did find it. And in Manitoba, we find lots of cases where it's in the middle of the field. I know I've been given a description of where to go in the field for the sample, and I'll walk out there and I walk and walk and walk, and I'm not quite sure where I'm looking for because it's not in any obvious location. And typically I have to call the farmer if he's not out there able to give me a hand and ask specifically, where specifically am I supposed to go? And eventually we do find it, but it's not at the approach all the time. So if you're thinking you just need to look at the approaches, please don't. Look at any areas where you're seeing dying canola. So risk reduction, the first thing is increasing the years between your canola crop. As I said, 2 to 3 year break between canola, you're probably going to reduce your spore concentration by half. If you have a really high spore concentration to begin with, that's not going to make, you're still going to see galls. If it's moderate to low, you're going to see a huge decrease in any sort of symptoms you see on those roots. Control your canola volunteers and host weeds. Doesn't matter if you're not growing a canola crop, if it's full of volunteer canola or weeds that are susceptible, like the ones in the brassica species, wild mustard, shepherd's purse, you could potentially be having clubroot, and the clubroot increasing the concentration in those spores based on feeding on those weeds. Scout your fields regularly and pull out plants that are dying or stressed out or injured and identify what the cause is. Don't just assume it's something else, a wet spot, a spot that's dried out because it's on a gravel ridge. In lots of years, it's the dry years where farmers were finding clubroot, here in Manitoba and Alberta as well. In the wet years, the spot was typically drowned out and they just assumed it was a wet spot. It's in the dry years where the rest of your crop looks fine, even those low spots and other places look fine, but it's these few spots that are dying, and just go figure out what's going on. Test your soil, field approaches, water runs, low spots, areas of prematurely dying canola. If you can't see symptoms, you can't really identify what's going on, test the soil. It's an amazing tool. The technology has come so far in the past 10 years to being able to identify whether or not you have spores in your soil, even at really low concentrations. We'll grow a clubroot resistant variety. There is a debate on this, whether or not you should be growing the variety from the get-go, or if you should be only growing it when you know that you have a risk. If you grow a clubroot resistant variety and you don't have any clubroot in your field, you are not, overusing those genes that are in that variety, because there's nothing for that variety or those genes to combat in that field if you don't have clubroot in that field. If you are growing it in a field where you do have clubroot, yes, that resistance is going to make a huge difference. The clubroot is not going to be able to infect and cause galls, and then those galls are released back into the soil from that variety. So just to go back a couple slides, if you think of those galls that we saw in the soil, so those kind of that swelling of those roots, that's just like a little clubroot factory going on in there. So the clubroot infects it, the clubroot, develops in that gall, it's growing, it's multiplying, it's making lots and lots of new clubroot spores in there. And then when the gall starts drying up, because that happens in the fall, if you go look at fields that do have clubroot, the roots look like peat moss, all those spores have gone back into the soil. So if we can reduce the spores from developing in those roots, we're reducing them and more being released into the soil. So that might be something to consider, even if you don't have clubroot. If you're concerned about it, it is a really good form of protection. But if you're growing a clubroot resistant variety, please keep in mind that that variety and the resistance held in the variety is not bulletproof. It's resistance, it's not immunity. If you are still growing canola, or canola wheat canola, the actual population of those spores in the field, and we call them races in clubroot, it can start because it's reproducing so quickly and producing more spores, chances are there could be a couple spores in there that are not the race that that variety is resistant to. And then you can have, in that specific field, if you, the next time you go and grow that variety or another variety that has resistance to that specific race, it's not going to work anymore, because that race has become the most dominant one or more dominant in that field, and it's going to overtake that canola because there's no resistance to that race specifically. So keeping in mind rotation, increasing your years in canola isn't only going to protect you from the clubroot building, just naturally building, but it's also going to help you with building up resistance to the genetics. And cleaning your own equipment when you're moving from field to field, trying to remove as much soil as possible. And I know this is a hard recommendation to give and to take, because sometimes in Manitoba we only have a few days where we can get out and we can actually seed. But when I see I'm really close to my time already, whoops. So trying to reduce some of that soil movement from field to field, because clubroot is a soil-borne disease. It moves with that soil. If you can reduce the soil moving from field to field, you're going to reduce the clubroot spores from moving from field to field as well. So cleaning equipment, if you can, using compressed air that you maybe have in your tandem truck already, having a wand, having a big shovel and trying to shovel off some of that dirt, or a broom or whatever, just reducing some of that load will go a long way. And then before buying used equipment or getting custom applicators to come onto your field, request that it's being cleaned. If you're cleaning your own equipment and you're taking all the precautions, they're going to see that you're obviously serious about this, and requesting it to them, they're not going to have an issue. If you're not doing any of these steps yourselves, they're probably going to question why you want them to clean. But it is another thing that you can keep in mind. If you do have fields that do have clubroot, going in and seeding them last, or doing your tillage operations in them last, and then cleaning your equipment really well after that field specifically, might be a time management tool, because you know the field that's infected, and then you're not spreading that field. But all your other fields are fine. You know, there's a lot reduced risk of spreading it from a field that doesn't have it to another field that doesn't have it. So this is just some pictures I took of some of the pipeline construction that they're doing. They actually went through here after all their equipment moved. They did put down the pallets. They went through and they actually cleaned the road afterwards, which I thought was a really good idea. It just kind of reduces some of that dirt that would be on that road that many people are driving through. So quickly to wrap it up here, just talking about break periods between crops. I'm going to go over this. So within that crop data that we looked at, of looking at crop on wet stubble, we actually analyzed it a little bit further to see, you know, what years really are we getting our best bang for a buck. So this is not necessarily statistics, but it's looking at in fields where that are orange bars, they show yields higher than average in 80% or more of years. So in 80% of the years that we looked at this, they were having higher yields. So spring wheat on spring wheat is bad. If you have a 1 year break, 2 year break, or 3 year break, you're seeing over 80% of the time you're getting an increased yield. In oats, it's a no break or a 1 year break. It's really, you need that 2, 3, or 4 year break before you're seeing that increase in yield, or consistent increase in yield. Grain corn, it's actually a 3 year break. Barley, 2, 3, or 4 year break. In soybeans, it's a 3 year break. So if you're thinking of growing soybeans on soybeans or soybean wheat soybeans, maybe shy away from that, because it's not really till that 3 year break or even that 4 year break you're seeing any yield gain at all, but it's really that 3 year break where it's consistent. In canola, you're looking at a 1, 2, 3 year break. In flax, oh, I think I have another slide here which shows it better. Here we go. Okay, flax is a 3 or 4 year break. Field peas, you're looking at 4+ year break, and here we have our soybeans again with a 3 year break. So looking at not only not planting crop on crop is bad, having a bit of a break is good, but looking to see where you're getting your best bang for your buck, if you're trying to figure out where to put these crops in rotation, this information is all in Yield Manitoba in the 2018 edition, so it's the one that came out last February. All these charts are in here, so you can go look at that yourself. So if you do have any questions on this, our main office for the crops is in Carmen at 745-5660. You can call us and somebody will be able to answer your questions. if you think you do have Clubroot, Manitoba Ag, we do offer free testing and confirmation. You can also call the Manitoba canola growers now or look on their website because they do have that offer out there that you can submit samples for free. And just to show you this, we are doing a bit of a Clubroot tour. I'm not actually involved. It's Dane Fraze, the oilseed specialist for the province, and it's being funded through Manitoba Canola Growers, and he's going all over the province to talk about Clubroot. So it's going to be a lot of the same information that I provided today, but it's going to be a lot more focused on Clubroot, as well as there's some people there from the Canola Council, and they do have the resources talking about the soil testing. So the closest one to you guys might be Deloraine on March 5th. I also see Neepawa and Brandon. They have one in the morning in Brandon and one in the afternoon in Neepawa. So you could be going to listen to Dane there as well. If you do want more information on this, if you look on the Manitoba Canola Growers website, they do have this chart here as well. This chart, I think, should be up in most of the ag offices too. So if you go into your Verdon Ag office, this will be there as well. Or if you are on Twitter, the Manitoba Canola Growers has this tweeted out with this chart. I know I've liked it on Twitter as well. I think Dane has too. So you could see this there as well. With that, if there's any questions.
I got a question here. Is there any other disease or anything else that could look similar to clubroot when you dig up the roots?
Yeah, so one thing that isn't a disease is, and some of you guys and girls might remember this, if you spray 2,4-D too late on plants, it can cause some of that root swelling as well. So that could be one of the things that you're looking at. But then with that, you kind of get that epinasty too, where the plant's all twirly-whirly and the roots are actually splitting. So, but that can look like that initially too. There's also something else called hybridization that happens in canola. It has nothing to do with it being a hybrid, but you can get kind of these little lumps and bumps all along the root, but it's not galls, it's just little tiny bumps, and they all have hairs coming out of them. So it looks a little weird, but it's not clubroot. And actually those canola plants look really, really healthy.
Okay.
They're not dying.
Good. I wouldn't mind touching on a couple of these questions that we have as well here before we wrap it up. One question then that I got here a few days ago was, well, if we can't stop clubroot from blowing in, is there any point in trying to improve the rotation on the farm? If we're getting it anyway, you say it moved 30 kilometers every year.
Yeah, so it's moving in the waterways, but as Soren had said, it can also move in the wind, which I forgot to mention. Just kind of those fine dust particles that are blowing off fields, that will move the clubroot as well. So if you are getting some of the erosion that way, either through water where you're getting soil erosion or you're getting wind erosion, it is going to move small amounts of the soil and small amounts of clubroot into your field. And if it is in your field, it's still at such a low level. Crop rotation is going to have a huge impact. Using resistant varieties are still going to have a huge impact. I think we need to stop thinking about all the ways that we can get it and who we're getting it from, or if we're getting it from somebody, and start to think about your own operation as how are you going to kind of bulletproof your operation for if you do get it, how are you going to reduce it and keep it manageable, or trying to reduce getting it in the first place. So crop rotation, resistant varieties are a really good way to do that.
Okay. There's a lot of talks about using lime to suppress this clubroot. I don't know if that's the right term for it or not, but we see some of that out of Alberta. Do you have any comments or any experience with that?
Yeah, so the theory behind that is clubroot operates at an ideal pH, which is typically kind of 6.5 and lower than that, so a little bit more acidic. And using the lime brings up your pH to more of a basic or neutral. In Manitoba, we have very few soils that are actually at 6.5 pH. Most of our soils are at 7 plus. So liming, it might have a bit of an impact, and where they're seeing an impact is kind of in greenhouse studies, not in real life field studies. but I think you would probably run into a lot more issues with the liming with your general crop production than just controlling your clubroot. So one, it's extremely expensive, and two, in raising your pH that much. There's other issues with crop production with too high of pH in soils, and actually the salt that you're bringing into with the limes, you're going to have other issues. So I really don't recommend liming.
Okay.
I know there was another question before about breeding, and if our breeding is going to stay on top of this resistance. The thing with breeding is it takes a long time to actually integrate some of those resistance genetics into a variety. Every time that they put one in there and then that resistance is broken because of overuse, which tends to be the issue, it takes a little bit longer for them to get another one in there. As I said, Clubroot it's a worldwide issue. We are integrating a lot of genetics from a lot of different places in the world. We're even integrating them from other brassica species like radish and turnip and broccoli and lots of other fun things. And it does take time to integrate it into it. And the breeding companies and the developers of some of these genetic traits are really, really smart people. And they are trying to integrate more and more genetics to different races too. So you could have a variety that has a kind of a multi-race resistance to it. But it is up to the producers and the ag industry as well to promote crop rotation definitely, and maintaining that resistance and not overusing that resistance, just to keep it in the system long enough and keep it working long enough so that more resistance can be brought into the next varieties. So definitely breeders are keeping up to it, but it's part of our role too as producers not to overuse those genetics and to basically break them faster than they should be broken.
I think that's all we have for questions for right now. Did you have anything you wanted to add, Anastasia?
No.
I'd like to thank everyone for taking the time, and thank you, Anastasia, especially for taking the time to do this once again for us, and hopefully it was valuable information to those who took it in.
Okay, thank you.
Thank you. Take care.